Welcome everyone to another episode of Around the Block Talk. Today we have with us Mr. Phani Arega. He is an industry veteran, having served in the leadership position of various firms and projects. He is a subject matter and industry expert in the field of blockchain. And I'll hand it over to you, sir. I'm very excited to hear what you have for us. Thank you.
Thank you, Pratik. And very good morning to you all. Let me introduce myself a bit and then we get on to the presentation. Is my screen visible, Pratik?
Yes.
Okay. So I have more than 25 years of experience in software industry across India and US. I have worked on different technology platforms. In particular, my expertise is on blockchain and database. I'm a technical editor of books, author, speaker, blogger, and trainer in these areas. I had filed 2 patents. I also have authored an ISO standard for blockchain. During my tenure as the Senior Vice President heading the engineering at Zebi Data, we built a private blockchain platform. Zebi's own private blockchain platform is among the first to go live from India. Zebi's own public blockchain platform, also the first to go live from India. And we built several dApps. Among them, one was a land registry dApp, which was the first to go live across the world in the domain of land registry. And we also built a big dApp on Hyperledger, which is perhaps one of the biggest in the world in terms of the data volumes involved and the data ingestion rate. We also have launched Zebi's crypto token. Initially, it was on Ethereum, and later it was migrated to Zebi's own public blockchain platform. And we also did an initial coin offering. ICO is like an IPO, but it is done with the cryptocurrency. And we raised equivalent of $10 million for Zebi. So I've been ranked among the top 50 influencers and thought leaders in blockchain and in cryptocurrency over the last 2 years. I'm also selected as an industry expert associate in the University College of London Center for Blockchain Technologies. I'm a graduate of IIT Madras. In the past, I had worked with Tata Consultancy Services, Quest, Oracle, and Zebi Data, and I'm currently technical advisor for Zebi as well. So that's about me. Now let's switch on to the topic.
Sure, sir. Thank you for your introduction. We can move to the topic.
Yeah. Okay. So, so the topic for the day is where and why is blockchain used. So I'll start with a brief introduction of what blockchain is, how it works, and then get into what is so special about blockchain because of which it is having such extensive usability. And then we'll go into where all blockchain is being used in the industries. So, so if you look at Wikipedia or do a Google search, the definition of blockchain you'll find is like this. A bit of jargon here. A decentralized distributed ledger running on multiple nodes, which groups transactions into blocks that are cryptographically chained or linked. So yeah, this terminology is a bit overwhelming, but let me simplify that by explaining each term. So what's a ledger? Ledger is basically a record of the different transactions or events occurring in a certain system or a certain place. So a node is it's a computer system in the network. So decentralized, this concept of decentralized is very important. That's a big differentiator of blockchain compared to the non-blockchain systems. So decentralized means it is the opposite of centralized, where a single system is the authority, and whatever is decided by the single system is the source of truth. Whereas in the case of decentralized, it is democratized. So the source of truth is decided jointly by the different constituents in the decentralized system, and only the source of truth that is agreed by majority of the nodes or constituents is accepted. And what are the implications of that? We'll talk about that later, but this is the meaning of decentralized. Distributed meaning it is physically in different computer systems, and typically in blockchain the different nodes are geographically separate, and they are under separate custodians. And it's not that one is the primary node and data is replicated from that to the others. Each node is independent. Each node has its own copy of the entire data and the entire software that is required to run any transaction. So it is different from a primary and a secondary concept, different from a master slave system of replication. Next is the term called block. So block is it's a logical thing. It's not a physical thing. Basically, a set of transactions occurring in a certain time period are bucketed into what is called as a block in the blockchain. So as I said, this concept of decentralized is something that makes blockchain special and brings some additional benefits to blockchain which are not available with the centralized systems. So let's understand the meaning of decentralized a bit more. So if you take the example of, let's say, Amazon.com or Amazon.in, or let's say the uh, railway ticketing system in India, IRCTC. So they are all centralized systems. So they are managed by a certain company or a certain organization. So and whatever is the transaction result according to that system is accepted as the source of truth, and the consumers accept it because they trust the operator. And so when I say single computer system, it need not in physically it may be containing multiple CPUs and storages for the purpose of load balancing and scaling and failover. Um, uh, but logically, it's a single system, meaning whatever transaction is performed on one of the nodes of the system is accepted by all the others without any verification or disputing. And the data, which is the source of truth, there'll be a single logical copy of the data, whereas in the case of decentralized system, each node has its own independent copy of the data. And so again, physically, if you look at it for the purpose of failover and performance and high availability, there may be multiple storage devices being used by systems like Amazon.com or IRCTC. But still, even though there are multiple physical copies, it's a single logical copy, because all those physical additional copies are exact replicas of the master. So the transaction result and the state is decided by the single computer system's program result. Whereas in the case of decentralized, each system will execute the transaction using its own copy of the code and its own copy of the data. And the transaction results and state are compared across the nodes. And only when there's a majority of the nodes agreeing on it, only then it would be accepted and made permanent. Centralized systems, so typically it's a single custodian, be it the Amazon company or be it the IRCTC department. Whereas decentralized, it will typically be under different custodians, and those custodians might be business competitors, etc. And there is and this centralized systems have the single point of failure vulnerability. What that means is if there is a one critical uh, piece in the architecture of the system, which, for example, let's say, or the gateway, the load balancer or something. So if that is broken by a hacker, then the system will not be functional. In the case of decentralized, that problem is not there. Even if one node goes down, all the remaining n-1 nodes are available, and the remaining nodes are equally capable of performing the duties of the node that went down. So the application can switch the connection from one node to another. So our system availability is not compromised. So why is blockchain so called? It's a chain of blocks. So so the chain we are referring to is a cryptographic linkage. Okay, so far so good. We talked about what blockchain is, and how blockchain is different. How a decentralized system is different from a centralized system. So what? So what does that mean? What is the benefit that comes out of it? So which is what is more important to the industry. The other aspects of what it is, how it works, that's more of academic interest. But from the industry standpoint, what does this mean? What is the implication? So blockchain brings two key benefits compared to centralized system. One is trust, which which is the major one, and the second is removal of single point of failure vulnerability. I just mentioned about the single point of failure vulnerability a while back, and that is actually a smaller benefit compared to the first one, trust. So what do we? So the kind of trust we are talking here is about two completely unknown parties, or mutually non-trusting parties, being able to do a transaction uh, with confidence and without any risk of being cheated, and the transaction being settled fairly to the satisfaction of both the parties. So that is the level of trust we are talking about. So when the blockchain system is bringing the trust, even though these two parties, they don't trust each other, they trust the blockchain. They trust the data on the blockchain. They trust the smart contracts running on the blockchain to give a correct result. So what is the implication of that, of the trust that everybody has on the blockchain? The implication is this: in the absence of blockchain, these parties had to engage a third-party intermediary, a trusted third-party intermediary, to act as a neutral umpire, uh, so that the parties don't cheat each other. It is also called as escrow in some areas. So with blockchain, there is no need for hiring an escrow, because blockchain itself acts as an escrow. Okay, so what does that mean? What is the benefit of not engaging in an escrow for transactions? So these are the benefits that come out of it: faster transactions, because so typically if you have a escrow or a third party intermediary, for every step it has to be communicated to the escrow, and the escrow has to validate it and okay it. Only then the next step will be triggered. So it takes longer time. For example, like the if we do actually a telegraphic wire transfer of money from US to India, it takes a couple of days. So the reason is there are so many intermediaries involved, and there are so many verifications and checks done. And next thing is transactions become cheaper, because there is no fee that needs to be paid to a third party intermediary. That fee is saved. And in the past, uh, for very small transactions, engaging a third-party intermediary or an escrow was impractical and not actually worthwhile, because for small transaction amounts, it doesn't make sense to have an escrow with a higher fee. So those transactions were not happening at all. Now, those transactions can happen. They are practical and actually worthwhile. So more transactions will occur, and the business would increase. So this is the key factor which drives a lot of use cases of blockchain in across different industries. So we talked about blockchain being a trusted system. It's also nicknamed as trust machine. Why is it trusted? So that's the next question. So why do transacting parties who don't trust each other, why do they trust the blockchain? We know that blockchain has decentralization, and blockchain also has immutability for the data and also immutability for the software on the blockchain. So what is the degree of this immutability, and how blockchain is able to accomplish this immutability? We'll talk about that in subsequent slides. And we already have talked about decentralization. And now this immutable program and immutable data will give immutability to the transaction results and the state. And this decentralization will facilitate joint ownership of the processing system and joint ownership of making each decision. So when both the parties in the transaction are having a blockchain node, and both their nodes are giving the same result for the transaction, so naturally they would trust the result. So these two things, the immutability and the joint ownership, is what is bringing the trust on blockchain among the transacting parties. Okay, and we're talking about the data in blockchain being tamper-proof, the program on the blockchain being tamper-proof. So let's spend a few minutes understanding what that means actually. So, for example, if you take your online banking software. So let's say I am a customer of ICICI Bank. I go to ICICI Bank, and I go to their online banking portal. And for me to do a transaction, I need to log in. So there are a good number of checks and balances. There is a username password authentication. There will be a second factor authentication, which is a OTP or a biometric. And there is a role based access control, and there'll be an audit trail of which user logged in, when did the session log out, what are the steps performed by the session. All those will be there, and if there are some suspicious activities listed in the audit trail, it will trigger alerts. So all those checks and balances are there when the data is accessed through the application. So this is like the front door of the house, which is reasonably secure. But the problem is there are other backdoors which are not, where this security will not apply. All these the username password authentication, two-factor authentication, those things, they will not help in certain kind of backdoor accesses. So one such access is by a system administrator, a malicious system administrator, who has the super user passwords. So they can directly access they can directly access the data in the database, and they can alter the data to benefit someone. And even if there is an audit trail log at the database level, the super user has access to delete the entries in the audit trail log, so that there's no trace of this malicious tampering operation. The same thing can also be done by a hacker who's able to break into the firewall and who's able to crack the super user password. And the same thing can be done by a malware software or a worm which is able to get onto this machine and and if it is able to get the super user access by cracking the passwords. So this vulnerability is always there in the non-blockchain transaction systems. Whereas in blockchain systems, even these backdoors are also fully secured. Even for a malicious system administrator, it is not feasible to change the data. Okay, next thing is so how is blockchain implemented, or what are the building blocks in blockchain? It's not an entirely new technology. So it is built using a lot of existing technologies. So the distributed systems concept was existing for decades from the 20th century itself. Cryptography was very much there in the 1980s and 1970s. So the new inventions that were brought in with blockchain are, one is the consensus mechanism. So this is the consensus of between the nodes to agree on result of transactions. And so there were some new peer-to-peer communication protocols which were created so that the consensus can be done very efficiently. So it's not an entirely new invention. It's an intelligent combination of existing computer science concepts facilitated by a couple of new inventions. Next thing is how is blockchain able to accomplish the immutability or tamper-proofness? So this is a bit technical. So for the technical buffs, or for the computer science students or the software professionals watching this can so this is targeted for that audience. Others may skip this. So cumulative hashing is basically creating the cumulative hash of a block. For example, if you take CH2, so CH2 will have set of transactions and the result of transactions. So that is the data. So hash H2 is made using the data 2, and hash CH2 is made using the H2 and the cumulative hash of the previous block. And in the same way, CH3 is made using H3 and the cumulative hash of the previous block. So because of this, what happens is if the data in this block is tampered, H2 has to be recomputed, otherwise it will be out of sync. And CH2 has to be recomputed by the hacker. And now CH2 and CH3 become out of sync. So hacker has to recompute CH3, after which CH3 and CH4 will become out of sync. So they have to recompute CH4, and it goes on. So if there are thousands of blocks, to break the do a tampering and solve the inconsistency, they will have to end up doing the cumulative hash of all the subsequent blocks. So in some blockchain mechanisms where they have a consensus mechanism like proof of work, recomputing the hash and the cumulative hash of a block is very expensive. So this cumulative hashing, when coupled with the proof of work consensus mechanism, is a very effective way to keep things immutable and tamper-proof. We already talked about decentralization. Okay, so so we talked about what blockchain is and how it is built, and very briefly about what is special about blockchain. So now we can look at the industry use cases. There are several industries where blockchain is used. One of the biggest is BFSI. So in banking, for sharing the KYCs of customer or prospect customers across banks, blockchain can be used. And for reconciling the interbank payments, blockchain can be used. And of course, to prevent data tampering by malicious insiders. So as early as 2015, some banks in the US, they formed a consortium to explore usage of blockchain. And the result of that is what is called as Corda. That is a technology like blockchain, which is suitable for banking, and that is being used in production now by multiple banks. Even in India, in 2017, multiple banks got together and formed a consortium called as Bank Chain, and to explore the use of blockchain for different use cases. Insurance, subrogation, which is the dispute settlement. So that's a very tedious process in the insurance sector. So with blockchain, that gets speeded up, and then processing of the claims. So these are some examples. State Farm Insurance in the US was trying out this auto subrogation using blockchain. AIG Insurance Company and the software vendor IBM did a pilot to have a multinational insurance policy prepared by smart contract. So one of the initial adopters of blockchain has been BFSI. So in 2017, 60% of the blockchain market was from BFSI. Okay, and then other use cases of blockchain. One is other use cases is the land registry. We know in India we hear a lot about fake real estate transactions, fake documents, fake title claims, and in fact, out of the 3 crore pending cases in the Indian courts, about 2.1 crore are about the property ownership disputes. So having the land registry on blockchain will make that authentic and trusted. So several countries have tried it, and in India, the government of Andhra Pradesh has went live with land registry on blockchain for the Amaravati region in 2017. I'm happy to say that this has been delivered while I was in my previous company, Xavier Data, and this was one of the first land registry implementations on blockchain to go live in the world. And another big industry where blockchain is prominently used is supply chain. So it's used for tracking the provenance, meaning when the customer purchases let's say a pack of meat from a shelf in Walmart in the US. Using blockchain, they can accurately track where that from which farm in China or which farm in which country that particular meat has originated from. So the entire shipment history and the shipping path of the pack is tracked. What is the benefit of that? The benefit of that is when they have to do recalls. So let's say if it is known that the meat coming from a certain farm in China is infected. So with this system, they can accurately track what all lots have been have originated from that farm in China, and only those lots can be recalled and discarded. In the absence of this tracking of provenance, what will they have to do? They have to discard. They have to recall and discard all the meat packets that were for that week or for that month or whatever. And another benefit of tracking provenance is to identify counterfeits. So DBS is a big diamond merchant. I think it's UK based. So they track the movement of a diamond right from the mine to the customer. So if a certain original diamond is with store one, blockchain clearly indicates that the diamond has traveled from the mine to the factory and from factory to store one. So now another store two cannot actually claim that it has an original diamond because its claim will not be supported by the data on the blockchain, and hence will be identified as a counterfeit. And in supply chain, there's a lot of payment settlements between the transporting agencies. So that can be automated using blockchain. And trade finance. So there'll be a lot of small exporters who take loans from banks and financial institutions, and they ship and they export some goods, and so it will typically take a month or so for those goods to reach the destination and get into the hands of the buyer. And typically, like the buyer will be in a different country, and they are like geographically dispersed. So the settlement of payment if it is done manually, it will be very slow, and there's a very big risk of defaults and all. So when it is done by blockchain, as soon as the consignment is delivered, the blockchain would transfer the money from the buyer's account into the seller's account. So the payments will be very fast and prompt. And when a bank knows that these exporters goods are getting an automatic payment based on blockchain, like the bank also will be more comfortable to lend to the exporter. So these are the benefits of using blockchain in supply chain. And logistics. So like traceability, getting accurate status of where a consignment is. So basically the track and trace. So that's a key use case in blockchain, and even payment settlements in logistics. Identity management. So we talked about bank sharing KYC. Uh, a, a key requirement in many places in the world now is verifying the identity of people, be it at the airports or in high secure areas, etc. So typically, if you show your SSN card or your Aadhaar card to someone to identify yourself, so there is some element of compromise of privacy, and there's a risk of leakage of the PII data. Whereas with blockchain using zero knowledge proof concepts, so a foolproof verification can be done without the risk of compromising privacy. And another industry where blockchain has a good use is telecom. So one use case is payment settlement for international roaming calls. So let's say I make a call from Hyderabad to Los Angeles. So my carrier in India is Hyderabad, and in the US at Los Angeles, the carrier may be someone else, let's say Sprint PCS, and there could be an intermediary carrier also. So I pay my service provider Airtel for the ISD call, and Airtel has to share some of that with the Sprint cellular service of the US, and the intermediary cellular service which is facilitating the connection between Airtel in India and the Sprint in the US. So those things, doing them manually are very time consuming, and they're not trusted. There's a high chance of errors. So with blockchain, they are trusted and settlements happen very fast. In India, the TRAI, Telecom Regulatory Authority of India, to reduce the menace of unsolicited commercial communication SMS messages. So they brought in a mandate in 2018 that every cellular carrier, Airtel or Vodafone or Jio or BSNL, whoever, so they have to maintain blockchain system, and the consents given by the customers to receive or not receive uh, the commercial messages category wise. So that information should be stored on blockchain, and every commercial SMS message sent also should be stored on blockchain. So this is I'm happy to say that our company Zebi has implemented this for one of the telecom companies in India, and that is that was the big hyperledger implementation I was referring to. The next thing is healthcare. So the medical records, the health records, are something which are very confidential, and their access to the required parties is also very important because it makes a big difference to the treatment. So the goal is to have the medical records shared with the required stakeholders, especially when a person relocates from one state to another, or when they shift from one hospital to start taking services to another hospital. So in healthcare, typically the access log, the audit trail of who is accessing which patient's information and when, so that is stored on blockchain. The actual medical records themselves are not stored on blockchain, but the accesses are stored on blockchain. And next is the pharma industry. So US has passed a law that in US FDA has passed a law that all the drug companies, they should maintain a record of every direct and indirect raw material used in the manufacture of the medicines they are going to sell in the US. So typically, a lot of they import a lot of materials required for medicine manufacture, and each of that input material itself may be manufactured by using next level involved raw materials. So all that trail is stored on blockchain. So in fact, in 2015, these medical companies of the US came together and formed this Medi-Ledger consortium to implement blockchain for tracking the provenance. Education. So a lot of universities are now storing the educational credentials on blockchain. MIT, way back in 2018 or so, MIT has piloted doing giving the degrees and diplomas digitally and storing them on blockchain. And I think in 2021 or so, IIT Kanpur has created digital degree certificates and stored them on blockchain. And the universities in Singapore also are now issuing digital degrees which are stored on blockchain and which can be easily be verified whenever required. So, what's the benefit of storing degree certificates on blockchain? It will basically curb the menace of fake degree certificates. Energy. Um, so, so in energy grids where there are multiple consumers and multiple suppliers participating in the energy grid, so the tracking which supplier has supplied how much and which consumer has consumed how much, so that becomes very smooth, trusted, and quick with blockchain. So that is being explored, especially in Australia. There were some trials done with this. Another major use case of blockchain is that of cryptocurrencies and crypto tokens. You would have heard about all the buzz about Bitcoins, Ether, Tether, and all. and among the crypto tokens, there's a category called NFTs, non-fungible tokens. And with the crypto tokens and cryptocurrencies, ICOs can be done. So a lot of small companies, startups find it much easier to do an ICO compared to an IPO. So this cryptocurrencies and tokens is one of the other big use cases of blockchain. In fact, the very first use case of blockchain was Bitcoin, so which is a cryptocurrency use case. So these are the different use cases of blockchain across industries. Uh, there are some more as well. I have included only the key ones here. The next thing is why is the blockchain adoption not very high? Blockchain was invented way back in 2008, and the first Bitcoin implementation happened in 2009. So the question is why in this internet age, uh, so even after a decade, why is the uptake of blockchain so less? There are multiple reasons for that. One is the platform limitations of the blockchain platforms. So they are being addressed. Lots of startups and large companies are doing a lot of research and on this. So the number of transactions per second on the public blockchain now is low. So on private blockchains, the TPS is not such an issue, but on public blockchains, it's an issue. There's a lot of research and trials going on that. And next thing is inter-blockchain communication. Internet is so powerful because out of the thousands of systems on the internet, every system can communicate with anything else, and they can interact and make a complete transaction happen. Whereas initially in blockchain, the blockchain smart contracts can only access the data inside a blockchain. So if there are two blockchains, the first blockchain having some 10 organizations and the second blockchain having either 15 organizations, so they can't so a company in the blockchain one can't transact with a company in blockchain two. Even on this, in the last 4 years, a lot of research is happening, a lot of approaches have been devised. So hopefully in the next 5 years or so, both the TPS issue and the stabilization of the inter-blockchain communication will occur. Another reason is the Bitcoin stigma. So because of the anonymity associated in the public blockchains, so Bitcoin happened to be used a lot by smugglers or drug traffickers who want to evade the law. So there's a big myth about people that blockchain is same as Bitcoin. Actually, it's not. Bitcoin is only one of the use cases of blockchain, and Bitcoin became very infamous because of that, and so that stigma, so blockchain was remaining in that stigma shadow for a while. And next thing is blockchain is a team sport. If one organization decides to implement blockchain, that is not sufficient. So multiple organizations, they should agree to use a common blockchain. Only then the blockchain can be adopted, and all of them will derive the benefit. So multiple organizations which are usually competitors, they agreeing to use a common blockchain implementation is something that slows down things a lot. And next thing is the regulation, the cryptocurrency and crypto token legality and taxation. So that is not ironed out in many countries in the world. There are a few which have legalized it, but in majority of the countries, the regulation is still being decided. So these are some of the key impediments why the adoption of blockchain is low. So hopefully in another 5 years or 10 years, all these things will be covered and the adoption would increase a lot. So with that, I come to the end of this session. I thank you all for your time.
Sure. So thank you very much for that very informative talk. So in terms of a little bit of question answers, I think we can take. So sir, most of the implementations that we saw comes out of the property of trust in a blockchain. So,
Mhm.
but I believe there are other properties to a blockchain as well. So, do you think that only trust is right now being implemented, and other properties like decentralization, and so there are less use cases for other properties, is it?
Yeah. So as I mentioned, apart from trust, there's another minor benefit, which is removal of single point of failure vulnerability. So that is a second benefit, but not something as important as trust. So this is also something that is useful. To give an example, see, for example, when the ransomware attacks were happening, I think 1 year ago or 3 years ago or something. So the entire healthcare system in the UK was actually brought down because of the ransomware attack. So that's an example of a single point of failure vulnerability. So in the healthcare system of the UK, there would have been some servers which are actually whose availability is actually a must-have for the system to run. And if ransomware virus was able to attack and compromise those servers, so those servers are no longer available, and hence the whole system becomes non-functional. So whereas with blockchain, because of the presence of multiple nodes, so for the blockchain, for the functionality that is being executed on the blockchain, so that never occurs. Single point of failure never occurs. Even if ransomware or a hacker is able to attack and compromise a node, still the rest of the nodes are very much available, and so the system will continue to run. So the applications will just shift the connection from the compromised node to the other good nodes.
Sure. Sure. So, also, most many applications that we saw were consortium based. So, right,
Right,
supply chain and banks. So,
right.
in terms of implementation, do they use a permission blockchain or more like a public blockchain is also used?
Usually they use actually permission blockchain. So there are two types of blockchain. Due to lack of time, I could not get into cover this aspect. There are two types of blockchains. One is public blockchain and the other is a private blockchain. Public blockchain is 100% open to all. Anyone can become a part of the blockchain and run a node, and all data is visible to all the accounts, all the users. In the case of a private blockchain, the entry is restricted. Only authorized parties can be a part of the blockchain and run a blockchain node. And within private blockchain, there's one more concept called as permission blockchain, wherein the data access is restricted. So even though a party is allowed to join a private blockchain, it won't be able to see the entire data on the private blockchain. It will only be seeing the data that it is authorized to see. So that is that access control is there in permission blockchain. In most of the enterprise and industry use cases, the confidentiality and access control is required. So that's why majority of the use cases that I have shown you use private and permission blockchains. The crypto token and the cryptocurrency, they are the main users of the public blockchain.
Sure. So also now we are seeing in a lot of consumer products like NFTs. Instagram is incorporating NFTs on their platform. So we
Uh-huh.
are seeing consumer products coming on blockchain. So what is your views on that, and how will that expand?
Yeah, so there are two things here. One is the utility and other is the hype. So basically NFTs can be used to digitally represent an asset on blockchain and to transact the to buy and sell the ownership of that asset between parties, whether it is a complete ownership sale or a partial ownership sale. So it would make sense for things like where authenticity is important, and for expensive items where tracking counterfeits and resolving ownership disputes is important. So there, I mean, the selling and buying of the assets can happen without blockchain also, but blockchain gives NFTs bring in two or three benefits, which are the following. One is trust. So there'll be no uh, doubt about the ownership, and next thing is the confirmation of the authenticity and helps weed out counterfeits. And the third thing is it would facilitate fractional ownership. Which will actually democratize the ownership. So let's say there is a painting, or there is a house which costs 2 crores, 2 crores of rupees, or let's say like uh, $500,000. So one middle class individual may not be able to own the entire house. But with NFTs, fractional ownership is supported. So a middle class individual can actually purchase, so let's say 5% of the ownership of the house. So like that fractional ownership is made possible, and the selling also can be done for fractional ownership. This person who owns 5% of the ownership of that particular asset uh, can sell uh, can sell his or her 5% to someone else uh, without the independent of the remaining owners of the asset who hold the remaining 95% of the ownership. Even if they don't want to sell, they can retain their respective ownership, and this person can sell independently. So basically, buying and independent buying and selling of fractional ownership, that basically democratizes the ownership, and it will also increase the number of transactions. It's something good for the economy, good for the industry, and so on. So that is so these are the benefits that come out of it. So like there's also some people who are doing it as a investment instrument, thinking that okay, I buy an NFT now, and it will appreciate 10x after 1 year, so I sell it. So that is I think that's something that's basically speculation and a game that investors play. So I mean it's not because of blockchain, it's because of the kind of uh, trade, or the kind of game done by the investors. So buying and trying to um, create a hype, and trying to benefit from the rapid appreciation. So because of that, we see this rapid increase and decrease in the prices of NFTs and cryptocurrencies. So that is because of the speculation. So if that speculation is kept aside, and people stop using these cryptocurrencies and NFTs as a investment instrument, so then we will not see those problems of high volatility and all.
Sure. So also, what do you think are the opportunities for a nation like India in this upcoming technology, and what can be done over here?
Yeah, so many of these use cases are applicable to India as well. For example, so the Telecom Regulatory Authority of India mandating blockchain. I mean, so that's a very progressive step actually. Very few other countries in the world have actually done that, and several state governments have used blockchain to for things like for things like land registry, education certificates, and all. So blockchain has been consistently supported by different governments in India. So the government may be against cryptocurrency and crypto token, but as far as the blockchain technology is concerned, they have been fully supportive. Actually, Prime Minister of India Modi has he had made a couple of statements on Twitter about increasing adoption of blockchain, and the finance ministers, former finance ministers, present finance ministers, they refer to increasing the use of blockchain technology in their budget speeches also. And RBI is now coming to is planning to come up with a blockchain sandbox environment, which is like a trial environment which can be used. So, the one use case where it can be used in India well is uh, government subsidies. So the government subsidies, there is said to be a lot of corruption in it, and the actual amount that reaches the final beneficiary is very less. So using biometric authentication and blockchain based tracking, so a lot of transparency and accountability can be brought in that in India.
Right, sure. So, and apart from implementation, what do you think are the possibilities for blockchain firms or blockchain developers or blockchain professionals to come up in the nation?
So, so I mean, so blockchain developers are there are two kinds of work. One is they're working on the blockchain platforms, trying to improve the limitations on the platform side, and the other set of developers are building applications using blockchain, which are called as dApps, building applications for different sectors. So like it is a good skill. Like in terms of the size of the market, it will not be as big as something like AI or machine learning, because of the nature of the game. So if for example 10 companies are using blockchain, they'll use a common blockchain. So only one blockchain application is sufficient for them to use. Whereas if it is something like artificial intelligence or the other ERP softwares, every company will have its own application installation. So the number of installations, a number of instances will be lesser because blockchain is like a team sport rather than an individual sport. So in terms of the total market, so and in terms of number of jobs, like probably it won't be as high as the other ERP applications or AI. Uh, Now, but yes, it's an important technology. There will be some amount of jobs there, and they will continue to be there in future as well. It will increase once the platforms mature and the regulation is done and the standardization is brought in. The number of jobs will increase, and probably it will saturate at that. It may not. Now in the academia, there is a lot of there's a lot of requirement for blockchain knowledge. Most of the colleges, education institutes, they are starting teaching blockchain. So that is apart from blockchain developers who are building things for the industry. So blockchain skill requirement in academia is also there now.
Sure, sir. Thank you very much for your time and for the talk. And with that, we'll close it for today. And thank you for coming to the show.
Thank you for inviting me. Bye.